typically have a headset and am doing YouTube videos from time to time on DragonOs. Also C and Python and assembly and hardware, whatever you want to call it. Dev there with Mark. So yeah, I was asked to come on here, and I guess I'll just do some screen sharing. And if anyone has equipment, whether it's like Kali, I guess that you're running as the operating system should be fine, or if you have DragonOS, I'll try and go through some different things here that hopefully is of interest, and just so that everyone can learn from one another. I will speak the best I can to cellular stuff, but if I misspeak or you have something to add, jump in and add add as you please, I guess. So let me try and share the screen here. I'm assuming that everyone can see the screen.
Yep,
okay.
Looks good.
Okay. All right. So I'm not the most organized as far as like Windows coming and splitting terminals and everything else, but I was just checking this out beforehand. So if you're wanting to follow along, probably the most important thing is to have your HackerF loaded with firmware version 2023 or greater. I don't know how that impacts the PortaPack setup for people because I don't have one. But if you probably even get away with like the 2022 firmware and greater. And I actually put that firmware, if you need it, somewhere here. User source HackerF firmware, and then that date, and you'll find the HackerF 1 USB bin, and you can load that. I'm assuming some of this stuff, if everyone's familiar, I can jump forward, but you could use that SPI flash tool and flash the with the TAC W, flash the firmware, and then you might have to reset the HackerF. But then you should be set up and ready to jump to the next step here. So is everyone like in the US?
Yep.
I guess. Okay.
Yeah,
so,
most of us are, at least.
Most. Yeah, okay. Well, whatever. Yeah, wherever you're at. There's not really like the only like GSM here, and I guess I should caveat this with I honest to God don't know all the rules and regulations like off the top of my head. So typically I'll have like my own little GSM network to test some of this stuff. But let's say you wanted to check out what's around you. I only have PCS 1900 around here because the networks, that's about all there is. And let me make sure, yeah, so I've got my HackerF and GRGSM scanner. You could specify what argument you need, and then the band PCS 1900. I do a -G gain of 14, and the reason being is 14 is like kind of like the magic number with the HackerF. It's either 0 or 14 that turns the amp off, on and off. And there's other gain settings that can be set, like 2 other gain settings that can be set in the HackerF. And the GRGSM scanner doesn't like take into account those other settings. So deep down in the code, I just hard coded those numbers in the flow graph for GNU Radio to higher settings, taking into account, okay, most people are probably going to use the HackerF. And those are kind of hard coded. And then -V for verbose and -D for debug. I won't leave this run for a really long time because this GRGSM, which may be the same in Kali, is the how is it pronounced? Multi-arson branch. So it takes a lot longer when it's scanning because it looks for, and I'll scroll up and just show you. So this would get it started. You see how it's going, 0%, goes up to 100%. And let me Control C this because I've already ran it. And if we look up above, you're going to see the difference between the normal RGSM and the branch that I have in here. You come down, you start seeing, instead of just like one in the frequency, you're going to see all the individual, like 33405, 33406, 33407. And then you get the frequencies of those GSM cells or base stations. You see the LAC, MCC, MNC. If anyone wants to like dig a little more into or explain those, I mean, I vaguely like the MCC, like 310s for AT&T. I can't really remember the definition of LAC off the top of my head, but if anyone's got that, go ahead and share it, I guess.
So real quick, what's the CCH?
Right here.
Yeah. So South found like CCH, AR, FCN. What is that exactly? Is that just a device itself?
You're talking here.
Up 2 lines.
Oh, okay. Yeah, this whole line here.
Yeah.
So I'm more familiar when I get into like the next thing I'll show, like LTE 4G, and you take the IRSN and you can, I'm sure it probably applies here if you do like an IRSN calculator, that 33407. I'm just taking a guess here. Probably comes out to a downlink frequency of 1955.6. I know that's how it is with like LTE 4G. If we punch a code in, if you guys got the iPhone, I'll get there. You see the IRSN, and then you just go online to a calculator, and you figure out the downlink and uplink frequency for that IRSN. So, if you want to take a second, let me see. I'll pull it up on my phone here, but I'm pretty certain that if you Google IRSN calculator, scroll down to maybe 2G GSM. Let's see.
Keep saying ARFs, and I want to set something on fire.
Yeah. Let's see. Let's see. I was just checking here. 33407. Calculate. I don't know. I have to dig a little more into that. I'll show when we get to LTE, but I'm pretty sure that translates to that downlink frequency that's shown there.
Okay. Were you able to drop that line of code into Meetup text real quick? Sorry to derail you.
You want the command, you're saying?
Yeah.
Mm.
Just above. You Meetup text.
And also, as you go through this, I have a HackRF. I've never really used it for anything. So
Yeah.
if you could kind of just go, I'm scanning here, and this is the reason why. Like, why would you want to scan?
Yeah.
What's the useful information? What's the goal?
Yeah, no, that's a good point.
That'd be great.
So I would guess, or I would say that if you wanted to, well, ultimately what I'll show is like this particular set of tools and this workflow, the end result is going to get you probably a little more information than one should probably have, but it's all out there. It's open. There's some decoding going on. Obviously, I'm not showing anything that's decrypting, but the end result will show you the IMSIs passively just by sniffing the traffic. So IMSI would be like the identifier on the SIM card in your phone. So, if for some reason, I don't know, for probably not.
So wait, what you're saying is this is basically promiscuously sniffing out this wireless GSM traffic, and you're able to identify individual phones because that's the context.
Yes, yep.
Right on.
Oh,
Yeah.
that's fucking sick.
But I guess other purposes would be if you wanted to just see like around you, see what GSM, base stations and cells are around you. You could do a survey. You could probably combine surveys from several different locations and see, hey, like this is odd. Like, why is this particular? Maybe you're getting information that you've bounced off of, like what is it called? Wiggle Wi-Fi or whatever. How they have those cellular surveys. You can get existing cellular information from like the FCC, and so if you put enough time and effort into it, you could probably determine like, hey, somebody's running like a fake base station here, or this particular number, this frequency, this lack, this identifying information of a cellular provider is not lining up with what like should be here.
So that would be like a stingray detection.
Yeah, like if you're down, let's say, I don't know, DEF CON, and people are running around with like fake base stations trying to get your phones, attracted to it. You could run this. Likely, they're probably not using GSM, but there's some other tools that work like this. You could look it up on YouTube. There's, I wasn't going to really show it today, but Crocodile Hunter was actually shown at one DEF CON years back. And the whole point of that particular tool was to scan like LTE 4G networks to find, just like you said, stingrays, things out of the norm. And so that was actually talked about and demonstrated at DEF CON.
So let me ask you a question in general here.
Yes.
As you go through this, can you
Yes.
speak to what encryption is in whatever scheme is being used, and how much of that is like, just encrypting that payload, but the rest of this, which is like super useful, like, like how much does the encryption get in the way versus how much is like this doing any defeating of encryption, or literally are you just harvesting the stuff that's in the clear?
Yeah, and I wish I could get, like, I'll just be honest, I don't know the ins and outs of everything, but I have highlighted right there something that I do know, which is that A5/1, that is a level of encryption, but I can almost guarantee that you're not going to find any networks around here that's that A5/1, because that has been broken, and there's actually a few videos on YouTube about it. One that's even like really recent, and the guy's, funny enough, he's actually using DragonOs to do the video, and he shows step by step, if I recall, how to use what's called Kraken, and I think essentially Rainbow Tables is able to crack that encryption on GSM, and people have been able to basically listen to audio and other things that they otherwise shouldn't have been able to. But that's the only encryption that I know of that has been broken with GSM.
Is that a telltale signature of a stingray? Because that's one of the things that a stingray tries to do, is it will advertise itself with an older, probably that right there, right? And you're trying to get you're trying to broadcast a stronger signal, so that way somebody basically connects to you, but then your phone sees that and then happily goes to this crappy older scheme, which can be cracked.
Actually, that's a good point. And there is some like attacks that I've been reading about where they'll downgrade, like they'll force you off of like LTE 4G and try to get you to downgrade, just like you're saying, to something that's like older, and because GSM's still out there. So like if you go to another country or whatever, I would imagine that the iPhone, I don't know the modem and this, specifications on all the latest phones, but I would think that they're probably still accounting for the fact that maybe you're going to travel somewhere and there is only GSM. I mean, the fact that T-Mobile in the U.S. still uses GSM, that leads me to believe, obviously it's there for a reason. So yeah, that's actually, and I would love to get to that level of like demonstrating some of those techniques. I've just either not had the time or, primarily not had the time. But
Thank you.
no problem. What GRGSM scanner is doing though is literally like it sounds, just scanning on the particular band that you put in there, which is like 1.9 gigahertz something. There's a PCS 1900 is a is a standard. There's particular frequencies that it knows to scan on. That's all that's doing. This initial scanner is just getting you that piece of information to take it to the next step, which is, okay, I know that there's a particular frequency out there, a particular cell or base station that I want to look at a little closer. And that's where the other tool comes in, GRGSM LiveMon. Let's see here. And so GRGSM LiveMon, I just, you don't really have to pass it the arguments of HackerF equals 0. You could probably even leave that off if that is the only device that you have plugged in. That's really should be, if you had multiple software-defined radios plugged in and you wanted to pick a particular one, that's why you'd pass that. I actually noticed it seems like a bug because I had my Blade RF in a second ago along with the HackerF, and for whatever reason, GRGS LiveMon would not listen to what I was saying, and it was just continue to try to use the Blade RF. Let's see, you pass it the frequency with a dash F 1956 megahertz, which was one of somewhere up here, one of the ones that I found right here. And then I just passed that dash G gain of 14 again, turn the amp on, hit enter. And it all comes down to a good antenna, for one. How far away are you from the base station? The antenna, and you'll start to see the information coming across there. That's GRGSM and the GNU radio behind the scenes decoding. You want like a nice stream like that. It's gonna like it's decoding that particular GSM network. And so if I take it one more step, so now it's like I've identified the network with the scanner. I'm locked on that particular frequency. I'm decoding it. And let me find my window here somewhere. Pull up another one. In DragonOS, and this is maybe somewhere in Kali. I don't know exactly how they have it in Kali. I put a lot of the programs that's like essentially source code with other nice to have things along with it, which takes up like a pretty good chunk of space on DragonOS actually. And I put it in user source. So user source Cemaxecuter. And if we use sudo python 3 simple Cemaxecuter --sniff. And I'm just going to show this for a brief second because, and I think you all get the point, what's happening here. But if I start this up, we let it run for a minute here. Okay, that's good enough. So you can see that it pulled out from that decoding that was happening on the left some information here. So I can see the cell ID, the country, brand, operator, and if I let it run longer, it's kind of messed up looking here, but basically that's at identifying information. If I had the screen longer, the information would line up and you would get more information from the network to do exactly what someone said just a second ago. Like you're sniffing, kind of like you do with Wi-Fi, and you pull out that specific identifying information passively. Does that make sense?
Yep.
Hey,
when you get to the end of your presentation, if you wouldn't mind speaking, because you mentioned about the Blade RF. I don't have a Blade RF. I only just have the Hack RF, but I do know that the Blade RF is full duplex, and the Hack RF is half duplex. So that's all I know about it. But if when you get to the end, if you could speak about that a little bit, about maybe your likes, your dislikes.
Yeah, well, I think I could show something here that ties into this real quick here. For those that do have the Blade RF, I think I got screens all over the place here. So pretty big difference between the Blader F and the Hacker F being that half duplex, full duplex. And you're like, okay, well, what can I do unique with the Blader F? So if I reach over here, I have a Blader F XA9, and let's see, I'll just clear this window. If I go in user source and I open up what's called Yate, there's like Yate BTS. Okay, so I can turn the Blade RF into a GSM base station just by doing. Let me remember the commands here. Load. Okay, L. So the Blade RF has like a FPGA in it, and it needs loaded. And what is that? Fully programmable gate array, if I'm not mistaken. It needs loaded with a specific file that I have available in DragonOs that is just going to be used in conjunction with Yate BTS to bring a GSM base station. So I'll see if I can tie the Hacker F and the Blader F together here real quick. So I'm going to load my Blader F. That's loaded. I'm going to start up the Apache 2 web server. And the reason why I'm going to do that is, let's see. Brings you to this panel here, localhost NIPC. This is all built in here, and this is what you would manage, or what you would use to manage your GSM network. If you were wanting to do everything that I just demonstrated with the Hacker F internal, so you're not messing with like a real network or something, like you could configure, if you had enough equipment, the right equipment, you could test all this like in a little closed loop network. And to do that, you got to at least provide configuration here. So I picked my radio band. I already had this set up previously. I just put GSM 850. Picked a particular frequency. Actually, let me just change this. Let me change this to, let me think here. Trying to think if US was 850 or 900. 850 or 900. I'll leave it on 850 here. Let me see. Accept by regXP. Let's see. 310. I think I'm going to set it up to where anything that has 310 will be able to connect to this base station. Should be okay. Everything else.
Yeah, that with a regular expression where that asterisk means match. Oh wait, that's like multiple occurrences. If you were just looking
that's
for
a wild
substring-
card.
Oh, let me see. My
yeah,
bad.
Well, actually, a dot is a wild card for a single character. So dot star would be any number of random characters up to that point. So do you want it to start with that?
Yeah, I think is it like the example showing there? It's been so long, I can't remember. Like I just want to
Caret
basically
is a start of string.
Yeah, if you just want to search for any string that has 310 in it, just put 310.
don't even put the.
If you want it to like all strings that start with 310, put a caret in front of it. So
Yeah,
what's your goal?
It starts with 310.
Yeah, put a caret.
Okay, there we go.
Yeah.
Okay, so thank you. So let's save that. Come over. I should be able to minimize this. And if we do sudo Yate, throw a couple V's on there for extra like verbose. This should start up. Should. Okay. That's running. So I'm looking over. It should be transmitting. And if I do, let's see. So this is an Android phone sitting here. Let's see.
How did you get that thing there? What the fuck?
Oh, it's plugged USB into Linux if you use a program called SCR CPY screen copy. you just basically stream the screen over to the computer. It'll come up and ask you on the phone, like, you got to hurry up and, like, hit accept, have it in debug and developer mode, and then you can send it over to the screen there.
Okay, so you have a physical phone. You're just showing us on the screen.
Yeah. There's a.
Oh
there's
shit! I thought you had a virtual phone or something. I was like, what the fuck?
No, that would be actually pretty cool.
So what you're saying is, if you get all these little windows with your text scrolling by of your hack or whatever the hell, then you could actually pull up a virtual screen of some guy with some MC around the corner, right? And go be like, dude, what are you looking up on your phone, man? Stop it.
Yeah, freak somebody out. Well, let's see. So if I turn this off, let's see, airplane would be turned off. Yep. Let me just see. I'm trying to remember. So you can kind of see, you saw a bunch of like extra crap coming over here. You see it's on R for roaming. This phone is now on this network, the network that I've created. And I can't remember how to call Dave the IVR off the top of my head. Okay, let's see. So your allocated phone number, oh, here we go. So call David at 32843. 32843. So 32843. I don't know how you're going to be able to hear this because oh, wait a minute. I'm assuming you caught that, but so now this phone is on this base station, and if we wanted to say, okay, so let's see, 891.601. So if I come back over here, what did I say? 891.601. 891.601.
So, dude, if your neighbor was like trying to
Oh
look at their
gosh,
phone, they'd be going, "Who's David?"
yeah, that would not be good.
Would they see it?
Well, yeah, I'd probably be in big trouble at that point. Like, yeah, this shouldn't go more than, like, I mean, in my little closet space here away. It's not amplified or anything like that. It's got attenuators on it, so it's not going to go very far. But
Yagi.
I do remember going and doing a demonstration somewhere, and somehow or another, somebody's may have been a random phone that connected. So definitely, probably not good to do this. So I don't know if I can see. This is what I was talking about, where even though I've specified the hack RF, it's trying to use the blade RF. Of course, the blade RF is in use, so not quite sure what's going on there. I'll have to look at that later, but. You could set up, the point I was going is you could set up your like whole network and everything like internally if you wanted to do some training and demonstrate, and then you could use GRGSM LiveMon on the network that you created. So I can't think anything else with, is there any other questions on GSM? Like, I think I should probably move on. We're already 30 minutes in.
No, that's super interesting. You talk about LTE.
Yeah, why don't we, let me think here. Let me think. So turn this off. Turn this off. There's one other thing, but I don't think it would take a long time to get set up. But if you look up, let me think what it's called. Osmocom BB. So if you look up, yeah, Osmocom BB. I have sitting over here, I have a couple Motorola phones from God knows who, or I don't know how old these things are. It's like not even the flip phone, it's just like, it's about, fits in the palm of my hand, like that kind of Motorola phone, like you'd probably be sitting here forever to text somebody. And these particular phones, I just got them on eBay for like $10. You can take this phone and you can interface it with software on the computer, and you can turn the phone itself into essentially a fake base station. And there is some very sophisticated, like tools that's in Osmocom BB that can do some really crazy things. Like I've not done it yet, but it can get to the point where it can kind of act as a phone on the network. I mean, it is a phone, but it can, through the software in the computer, you can communicate as though you're a phone on the network, and start probing the network, and I don't know. You can screw with like sending SMS messages somehow through bypass, but that's all GSM related stuff. But it actually is pretty interesting considering, if you don't have an SDR like the Blader F and you're not wanting to spend like hundreds of dollars, you could get away with doing it with a little Motorola phone. Let's see.
So
So
is this one of those things in life that, like, if the government does it, they don't go to jail, but if you do it, you do go to jail?
uh,
Like printing
I
money?
I feel like, I mean, like, I would think that even with the military or something, there's a lot of like there's still like rules and regulations and everything. I've never personally done this. It's just like me, just trying to, kind of like a hobby, trying to learn, not trying to do anything malicious. I should caveat that with, like, a lot of this stuff, like I said, I have attenuators, or I'll run direct cables, or I'll try to shield it or whatever, because let's be honest, the FCC has all kind of rules and regulations, and as far as like transmitting something, especially like a cellular network, like that could become a huge issue.
I wasn't saying anything about you. I'm just saying,
Oh,
you
yeah.
know,
Yeah.
no. Yeah, I'm not. I'm not a Fed.
Yeah. Okay, just checking. Just checking. CID? No, just kidding. So so let's see. What else?
Not the Fed.
Yeah. Let's see. So somebody said LTE. So let me think. I was thinking of a couple different things. Has anybody got an iPhone? So I don't know the code off the top of my head, but if you
I
have an
have an
iPhone, okay. So if you got an iPhone,
Never.
yeah. Let's see. iPhone service code. You may be able to find something equivalent. There's probably something equivalent on Android. Essentially, you're looking for like a service code that will show you the cellular information, like of the network you're connected to. So on the iPhone, it's let me think here. I'm actually having to look it up because I can't remember off the top of my
star
head.
5005 star 25370 pound.
You could try that on the.
Oh wait, there's multiple. Never mind. Oh,
Yeah,
there's multiple. I found a
this one is. Let me see.
field
Star
test mode.
pound.
Okay,
It's something like star. I always forget how it starts. It's
star.
3001.
Okay, yeah, star 3001 pound
Yep.
12345 pound
Yep.
star.
Yep.
All right, I'm gonna do it.
5 star
1 pound.
call. You should get, like, I've got an AT&T dashboard and it shows me the Arson DL. Does it come up for you like that? So for me, I've got 675, which is a downlink of 1937.50. So if we still want to use, heck, is anyone else like following along? I don't want to like go like blast through this.
No, I'm still following along, and you're using, and this is for the LTE one, right?
Yeah, this would be for LTE. So let me think here. Urson 19357. So there's a tool in DragonOs. Maybe there is on Kali too. Trying to remember. Cell search. I compiled 2 different versions of cell search. One for the HackerF, one for the RTL SDR. And I have to, yeah, so this is an enhanced LTE cell scanner tracker. Simple one for the HackerF, if that's all you have. a lot of options here that I can't remember everything. Essentially, I just need a start and an end frequency. Okay, so TAC S and TAC E. TAC S. Let's say I go 1937 dot. I'll just. And every application is different. Like some might want M for megahertz, E6 for one, that ends up coming up 1.937 megahertz. What was the other one? E.
So I don't know any of this info that it shows me, other than maybe bandwidth and band info.
Does it say below that Urson DL? And then it's got
Oh yeah, it does.
what number you got there?
I have a 68661.
68661. So 68661. That seems. Let's see. Oh, interesting. Okay, so band 71, your downlink would be 624.50 megahertz. So that's what you would. I'm showing like if I didn't know that, but I don't want to sit here and like have it scanning forever. So I'm just putting something kind of close. What was mine? 1937. Let me just do 40 E6. Let me see if this
is that the exponential notation? What is that?
Scientific.
This.
Scientific notation, I mean?
Yeah, what is that? 6 zeros?
Okay.
Yeah.
I think that would come out like expanded out to like maybe ultimately like hertz. But
megahertz. So
or yeah, sorry. Like with
that's
all the
going
zeros.
to be that's going to be a 1.9 gig or 1900 megs.
Yep. Let's see. I'm just waiting for it to go through here. So if you didn't know like what is around you, just like with the GRGSM, you could use this cell search, this cell scanner with the HackerF, and you could say, hey, look, search from this start frequency to this end frequency. Yes, it's going to take a while. I think you can actually speed it up with maybe one of the options. I don't know.
Is there a step size?
Step size, no, but you got me thinking, PPM. So that's a whole nother thing. Like I think the RTL SDR has a very low, if not like zero, very close to zero. I think PPM error. Can't remember what PPM stands for. HackerF, I think, has a little bit more of an error to it. And I'll let it see if it finds it, but you could put like -P like 0 or 1 or whatever it is that you have, and this would probably like speed up a little bit.
Isn't that pulse something modulation?
Or let's see.
Like PWM pulse width modulation?
Parts per million.
PPM, TXO, PPM error.
100 ppm of 100 megahertz represents a variation in frequency of 10 kilohertz.
Did you find it? You find a definition?
I found a calculator.
Oh, nice. Okay.
Here, let me put that in the meetup text.
Awesome.
And it kind of describes it too.
Parts per million.
Well, that's what I saw earlier. Yeah, that's what it says on there.
So there's a particular program called Calibrate, and let's see, PPM probably says it in here, expands it out. But this Calibrate can help you determine, I think, the error if you're able to bounce it off a GSM network, given frequency. Build an oscillator which only guarantees, for example. Oh, yeah, my bad. Well, you guys are right. Parts per million. And it goes on to talk about how that error, like you can account for that with this particular program. But I'm jumping back because I saw this. This is scanning down through, taking forever. Bam. It found a cell here on that frequency, and you can take that information. If I hadn't got it off the phone, we could take that information, and then I think for considering what time it is, I think we'll take this information, and I'll do a little bit more with. I'll do two more things I think with LTE. I'll show a tool called Falcon, which we can now take this information and this frequency and this cell information, and I want to hone in on that particular cell. And what Falcon can do is breaks down. Let's see. Here we go. Fast analysis of control channels. This is a tool that I was using that I had hoped could like gain even more information on LTE networks. And sure enough, fast forward like a couple of years later, and I'll make that the final tool I showed. Somebody has built upon this Falcon tool, which can decode the physical downlink control channel of a base station and reveal the number of currently active devices. But this particular program didn't go into like any sort of identifying information like IMSIs or anything like that. But it's still like pretty interesting if you wanted to see like how many users are on maybe a cell, how many, like how much like upload, download each user is using. So we should be able to see that. But to do that, you're going to need something probably a little beefier, probably a little more expensive. Let's see. I'm going to grab a B205 Mini, which is a let's see. This is an EDIS SDR, and what frequency are we on? Okay, so 1937. Again, this is more like kind of just doing stuff that's survey in nature. I'm not showing any sort of like exploits or anything like that yet, but I guess if you wanted to get to that level, you should probably survey and have a good understanding of the networks that are around you before you take it to that next level.
We go into the mountains.
So let's see, 1937. So I'm going to go into the user source Falcon directory. Let's see, build source. I'm doing it manually. I did put a link under other. There's a link here that goes like pulls up the GUI itself, but I like to see like what's going on behind the scenes in case it's not working. I don't think I have to run sudo, but actually maybe I do. Sudo Falcon. This is going to pull up this interface, which, see, it's saying 19376. Try that. When you first start this application up, it's going to have use file as source checked. I got to uncheck that, put the frequency in that I want to focus on. There is some cell ID, PRB, and ports. So I'm going to leave it on 50, I think is the default. And if that doesn't work, we'll jump over to what it's saying here, 401. I apologize. I wish I had like all the definitions on PRB and ports. I don't off the top of my head. So, but what I can say is if this is going to work or not. So I'm going to look here. I'm looking at the B205 Mini being loaded. It's FPGA being loaded. Give it a second. And I'm looking for, is it finding any cells, which it didn't. So let's see. I thought it was 19 or 1935. One nine three seven five. 401. No.
Oh,
Yeah. Technical problems. Let's see. I'm gonna put a different. I'm gonna put an actual like dedicated PCS 1900 antenna on it. All right, let's see what we get now. Oh, it's gonna make me a liar. Let's see. What else we got? We got anything else? It's 1937. 7.7. It's I guess it gets awkward when not having people in front of me, so I can't see any reactions.
You're good.
It's just quiet. I'm trying to see like how else could I get better reception here.
It's all right, man. We've all been through demo hell.
Well, take off your attenuators, right?
This one does not have anything on it. Let's see. What's that?
You're coming a little quiet, whoever's talking.
It looked like it was Warlock.
Okay, here we go.
You know, it helps when I take the tinfoil hat off
Mm.
and the signals come straight in.
Come on. It's trying. Okay. Here we go. So let me do tile Windows Spectrum cell. All right, so I am looking, and so I'm kind of like down in like there's not real good like cell service here. I'm like very at the bottom. There's trees all around. There's not a lot around here. But what this is doing is breaking down, decoding that particular cell, and this UE. That's basically, think of that as the handset, the phone. These are the particular devices that are on that cell. And if, like I said, like if I had better coverage, this would probably be more stable, like a survey. This is the activity, both the uplink and downlink. Just think of it like bandwidth-wise activity that's occurring on this particular tower or this cell. Now you can't see any like this RNTI is like a temporary identifier that's assigned to the handset, so you're not gonna see like any unique like user information. But that really wasn't the purpose of this particular program. Like as you remember, it said it was basically I think used to like determine, hey, how much through output, how much load was being put on a particular cell network. But I guess if you wanted to observe and see, hey, is there something going on with the cell I'm connected to? Like, what is the theoretical like bandwidth that's like being pushed on this particular cell? This should be able to get you that information. But I guess thinking of it from another perspective, if you're like, for I don't know, whatever reason you wanted to make a particular cell network not work, and then you wanted to see like, oh, am I actually having some kind of impact on it? Well, this might clue you in, like if nothing's occurring on it, well, it's probably not working. Okay, so that was that Falcon tool. And then I guess, let's see, how we doing? Might be a little difficult to set up the last piece, but if you all have a few more minutes or so, I can try and set it up here real quick.
Yeah, keep sending.
Yeah,
Okay.
go for it.
So this piece of equipment is more like in the $10,000 plus range, and was sent over by some few individuals. This is a Edis X310. So if you look that up, it's about $9,000 for the chassis itself, and then you're looking at about another $1,500 or so per what they call daughter boards, SDRs that go into the innards of it. They plug in, and the daughter boards that I have, I think, are about the 10 megahertz to 6 gigahertz range, and there's two of them. So to do what I'm going to show you, as it stands right now, you need this particular piece of equipment to look at two different frequencies. You need it to look at the uplink and the downlink of the LTE network, both at the same time in order for this to work. And this is a fairly new tool, LTE, what is it called? Sniffer here. It's open source LTE downlink uplink eavesdropper. And you'll notice that it starts out about the same as Falcon, because if you read on down later in here, they actually credit, like, basically they built on top of Falcon and SRS LTE. And what I'm most interested in is which I think we talked about in the beginning, like the security aspect. So this can start getting you into, it's the first open source tool that I've seen for LTE that can get you like IMSI information. But on LTE, the IMSIs, best of my knowledge, really the only time they're going to be popping up is like maybe when the phone first turns on or first connects to the network, or maybe, I don't know, on and off airplane mode, something like that. That's about what I can find as far as like open source information. So to make this happen, let me think. I'm going to need a couple different things here running. So I'll use the Blade RF. I'll use the Blade RF as a LTE base station, and hopefully this will all run at the same time. So Blade RF is plugged in. I'm going to have to start up a couple things here, and this is all SRS RAN. I'm going to start up the EPC, which I think is like the LTE network side of things, that's going to handle all the connection information kind of behind the scenes. I hope I'm getting that right. And then, so two windows here. Let me see how I can do this. Sudo SR. Lots and lots of options. I'm just trying to look for an option to specify the Blade RF. And I think weirdly enough, they have it where it's capitalized. Let's see. So, oh shoot! Before I start this, though, I should point out to make this actually work, because I'm going to use a phone that I have here. I have a Pine phone that has a programmable SIM card in it, and that programmable SIM card gives me access to all the information I need for the phone to authenticate to the network, because it's not easy like GSM. Like, you can't just do open registration and any phone can connect. There's like other layers of like authentication in LTE, and so I had to edit this user database with this line of information here, which came from the SIM card that I purchased a set of 10. I think they're called Osmocom, or I'll find the information, put it in the chat. But you need a programmable SIM to make this work, and I've put that information in there. And then I've also edited the EMB with a particular MCC and MNC. Actually, now it's got me wondering. So let me see. Nope, I don't want 5G. SRS ran. Put this here if you want to have a lot of this information. Uh, 901. Okay, so the Sysmocom is the Sims, and their values are 901 and 70. So 901 and 70, 901, 70. All right. So if I bring this network up, this should be like broadcasting right now. Reach over. It's probably going to get loud. Turn the X310 on. Okay, so I have an LTE network now that's running. Okay, and let's see. So LTE network's running. I have the Pine phone here. I need to unlock it. I'll let it boot up. And I'll cheat here and use the, let's see. Ah, shoot. Okay, so the phone already connected, but I'll turn it off. 2, 3. Let's see. I'll try and put it back on airplane mode. So the Pine phone connected to my LTE network, and right there I can see it's IMSI because I'm controlling the base station. But let's just pretend that I'm not controlling the base station, and I'm wanting to do this like passively. Let me see. Try and turn this off. I need to come down, and I want to do the security API. Paste. And we'll replace these frequencies with, where was that at? Probably right in front of my face. Okay, TX frequency RX. Let's see. Okay. And with the X310, there is some settings. I don't think it'll impact anything that you generally want to set. It needs like a bigger buffer. The MTU speeds need to be higher. Let's see. Yeah, let's see. Listed identity. Okay. All right. Well, let's see if we can get the MZ here, and then we'll call this good. Okay. Let's see. Did we get it that time? No, we didn't. Let's see. And if you're wanting to sniff the uplink, you got to be, the phone has to be, or you have to be close to the actual phone, because the actual transmission on the phone is, back up to the tower is not very strong compared to the downlink frequency. All right, I'll give it just another second here. Let me see. I'll turn the tower off. I'll turn this off. So it might not. It might the demo gods might not be. Everything has worked pretty good thus far, but if you monitor this, I have seen the tool work and actually produce. Let me just make sure I've got turning on 3 functions for sniffer, MZ collecting, and UE. So just like in the example here, I have been able to get the MZ from the phone. Uh, I think I'll call it there. That's I mean, there's a lot going on right here, but this particular tool, I think, is going to continue to get refined, and you can send a lot of the information that you're sniffing on to PCAP files to then look at with, which I'm sure you probably all are familiar with, Wireshark, so you can really dig into any of the unencrypted traffic that's going on LTE that this sniffer is able to capture, even beyond just the MZs. Matter of fact, I'm pretty sure I was seeing through the PCAP files, I saw unencrypted calls from my phone, because the phone is Linux, and it was calling back to the Debian repositories, and I actually saw the URLs that it was like reaching out to. So I thought that was like pretty interesting.
So normally it's running encryption. Like, what type of encryption would a normal phone be running on LTE?
I don't know. So a lot of like the back and forth communications to the phone, or I'm sorry, to the tower itself will be encrypted. I don't know like what level or the name of that particular encryption, but what is in the clear is this, this MZ, some other identifying information of the phone. The URL was a like non-HTTPS. So I don't know if that's like why or how I was finding that in the PCAP files, but I found that pretty interesting. There's the TIMZ. So I've not really like played with this tool as much as I'd like. I was mainly focused on checking the MZ side of it, because it is the only tool that I've seen, like I said, open source, that has been able to do this and actually work. Although for whatever reason, it's not playing nice right at this moment.
No, fair. But what's the difference between TISME and ISME?
This TIMZ is like a temporary identification that is assigned when the phone, or when the phone connects, and that was like, I guess, their way of like the provider's way of what am I trying to say? Like adding an extra layer of so you couldn't just like track people's phones and stuff. I'm sure it probably has like something to do with that.
No, that's fair.
Yeah. I'm trying to see if there was anything else. I don't know. There's a lot that obviously you can cover, and why it probably keeps me busy with like being able to make just random YouTube videos, because there's like so many tools, just like, Kali has like so many like Metasploit and Airgeddon and Wi-Fi, and I don't know, like millions of tools that, for offensive security. I just feel like there is a ton of applications for software-defined radios and just an endless. I mean, it just always seems like there's so much more that you can learn and dig into. It's just like during COVID, I had like if you had me given a class during COVID, I probably knew like everything in and out because like it just kept me busy, you know.
No worries. I was just curious.
Yeah, but I guess I mean with that is there any other questions? I think probably could wrap it up.
Yeah. So let me ask you this: what's like the best? I mean, obviously you're using stuff that's tens of thousands of dollars, but kind of creeping up from the very cheapest, to that level, right? As you progress along, what's like the most bang for your buck? Like, would it be Blade RF alone, or
Do you want
like
to?
a combo of like Blade RF, just to kind of like cover, a lot of these phone related SDR
Is there do you
use
have any?
cases?
Do you have any interest in like like ham radio type like HF type
Yeah, it
traffic
could be.
or
It could be. I mean, I've got a like the lowest level license, I guess.
oh nice, okay, good.
I've got like that, I guess, technician license, whatever the lowest level is. But yeah, I know there's further certifications you can get or further licenses you can get for other frequencies.
Boy, I would say like the bang for your buck. Like I'm looking around at like the different things I have here. You would think like I should go get like a license, definitely. But like I have a U loop, YOU, I think LOOP U loop antenna kind of hanging by my window here. I don't have anything crazy outside yet for HF, but this U loop antenna attached to like an AirSpy HF I have. That's a pretty good, I think, a lower cost software defined radio for more specific to HF frequencies. The Blade RF, I think, only goes down to like 70 megahertz. So unless you get some kind of, what is this called? I don't think it's called an up converter. Maybe it is. I've got a box around here somewhere that will, it's like ham it up box. What is that called? Yeah, ham it up. So if you wanted to just spend a lot of money on one software defined radio, but you still wanted like HF, you'd probably need to spend a little more money on a box that it like offsets the free. It's like if you put
Not
it at like,
converter.
yeah. That way, if you put it at like 100 megahertz, really it's like I don't know, 20 megahertz or something like that.
So it's for all the use cases you can think of for what are fun related stuff or just this SDR stuff you mess around with, right? I mean, HackerF, that's nice, but it's half duplex, right? So having at least something that's full duplex is nice. So you get the Blade RF.
You get the Blade
Combining them
RF.
maybe.
Yeah, the Blade RF or another one that's kind of come back out. That's maybe a little lower cost, I think, is the Lime SDR. There's like a Lime SDR Mini 2.0 that's out. You'd still probably need that up converter because it doesn't cover as wide. It actually doesn't even, I don't think, cover as wide a range as the Blade RF, but that's more like in the $300 range versus I don't even know what the Blade RF, even the XA4 is at these days. Okay, so that's $540 versus I don't know what these things are listed at. Oh, this even actually gives you a comparison here across the board. So if you go on the Lime SDR Mini 2, yeah, they even have the Blade. Well, no, that's the older. That's the XA40. But you can get an idea of the frequency ranges. So 10 megahertz to 3.5 gigahertz. I guess they don't put the newer Blade RF on here.
Well, I mean, if you had a Hack RF and a Blade RF, that's pretty good for a lot of different use cases.
Yeah, actually, yeah, the Hack
Together.
RF, the Hack RF goes down to 1 megahertz. I won't say it's like the greatest, receive like sensitivity or whatever, but it actually, I've used it for like down into the HF frequencies. and not really had too much of an issue receiving. So yeah,
So it looks like for receiving sensitivity, it's got a wide, like a huge range
yeah,
compared to the Blade RF X40.
yeah. Well, this is the old Blader F. The Blader F XA4 is a 70 megahertz to 6 gigahertz. So closer to this right here.
Okay.
They just, I don't know, for whatever reason, they're not listing it here. I would say a pretty good, like a combo. I'm kind of fond of the RTL SDR just because it's just like $30 and it can cover a wide range of different things. Of course, it's receive only. The Hacker F, of course, you can put it in the Porta Pack and has a pretty unique feature, Hacker F Sweep. I don't know if I actually showed that, but there's a couple tools in DragonOs that can take advantage of this, the fact that the Hacker F can sweep at like, I forget what it is, like 8 gigahertz a second or something crazy. So you're not looking at an instantaneous like picture of the spectrum from 70 megahertz to 6 gigahertz, but it scans so quickly that you can look at a huge chunk of the spectrum and generally pick up if there's activity going on over a wide range.
Waterfall.
Yeah, because like normally you can look at a max of 20 megahertz wide with the Hacker F, instantaneous. But with the Hacker F sweep, you can be like, hey, I want to look at like 1 gigahertz. I want to look at like 1 gigahertz to 6 gigahertz. And it just goes like so fast, it gives the illusion or it gives the impression. I mean, you're like seeing things because it just goes so fast.
Right on. Let me ask you another question. So,
Yeah.
as far as you created this whole distro, right?
Yeah, this is kind of like before COVID, and just actually, let me turn this off before I forget.
So I mean, you got all this command line stuff, which is great. I could write,
Yeah.
take in all these settings, write a script or whatever. So, how much stuff are you packed in here? That like, are there any higher level applications that are specific to like a use case that you can just pull up and you got a GUI and you can start jerking around with stuff?
Oh yeah, absolutely.
Like, what are a couple notable ones? Like, or the main one?
SDR++, I'm not too fond of the actual developer. I don't know why. He's kind of like I don't know. He seems very rude on just in general. But let me see if I got the Blader F here. So this is more like GUI driven, I guess you'd say. So Blader F, okay, 6 megahertz wide bandwidth, play. Maybe. Okay. It's actually in my ear right now. I can hear the static, but so I'm like looking at, so in my ear right now, I'm demodulating FM 99.5 and I'm hearing the local radio station. So something as like simple as that, you can just like jump right into. You can get more sophisticated. You can tune into, say, I'm just going to take a guess for, I don't know, what's, so 70 meter ham. So, and I don't have a real good antenna hooked up to here right now, but you can start seeing like your local like DMR, I think, what is that, more like 460 maybe? Just trying to look real quick, but if there was DMR going on here, you can then take this another step. You can send the audio out of SDR++ into another command line application to demodulate the DMR and hear the unencrypted comms going on. Let me think. Like, so there's SDR++. There is kind of like another one of my favorites is SigDigger. If you want to get into more like a signal analysis. I'm not sure. Let me see. Okay, there we go. So they all generally have some kind of GUI. Something simple. No. And so you're back with like your traditional like waterfall. Here, same thing. You know, I can go local radio stations. This gets a little more crazy if you're wanting to get into like, you know, investigating or looking more into a signal. I can hold this push to capture. Now, you know, I mean, this is like probably like stuff that's just like way above my head right now. I'd have to take some time to get into it. But if you wanted to understand more about a signal itself, SigDigger is definitely the way to go. Like it has demodulators in here that you can mess with and just dig deeper and deeper into the signal and waveform that you're looking at. So there's that. A lot of the tools that I have linked here are all more like GUI, you know, GUI driven applications. I mean, you can go nuts. You can have GNU radio application. I have a patch antenna sitting out on my front porch here that's pointing up to the Iridium satellite constellation. I can pull stuff out of the like Iridium's traffic for aircraft that are talking over or sending basically status reports over Iridium. You can decode that. You can decode ADSB, like information just given off by aircraft in general. It's just like there's just so much, to be honest.
Yeah, right on. Thanks.
No problem. I guess for a flavor of Kali though, since you were asking about Kali, I don't know if Kali has this or not, but if you're looking more along the lines of getting into something like what Kali does, I would suggest, and you're familiar with like Metasploit, look at Mirage. And if you look at Mirage and you start looking at the guy's guide and his documentation, you'll see that it's getting more into like hacking protocols, gathering information, and it's got a whole slew of like hardware that will. I mean, I don't even have all of it. There's like trying to see if it shows pictures. I don't think it does. It does have like the use of like HackerF, all supported devices. So you got Bluetooth. I mean, BTLE jack device, Ubertooth. I think there's a HackerF. There's just a whole slew of different devices here. And you probably would notice that it looks more like almost like a Metasploit type interface. I don't even know what they oh, there we go. Okay. And so you can just dig into different modules. You can chain attacks together with this framework. So I'm on the side trying to get a little smarter on this. I figured I'd want to do a video on it at some point. But yeah, I think that kind of covers, unless there's like more questions.
You know, I will add this, that DragonOs is a place in Croatia, a little village outside of Zagreb. So
yeah, every time I Google,
we know where you got this from, man.
Yeah,
Okay.
right where
we thought it was invented in Mother Russia, but no.
Yeah. Well, I see it kind of pop up all kind of places on Twitter. I'm always like noticing the distinct background there and very unique places. I'm like, oh, I see what they're using.
No, that's super sick. I didn't think so. Like I have DragonOS here on one of my. I got several laptops just floating around that just run different distros at this point, and a KVM to control them all because I'm lazy. But but I think I really like how easy it was interplaying. I didn't have to worry about shit with Dragon OS. And I know I probably didn't describe that enough. You made the distro for it. But it really seemed a lot easier to plug and play, and everything was already on it, pre-built.
Yeah, I mean, I probably am not going about building it in the most or the easiest way to maintain, or maybe the quote, correct way. Like I'm sure Callie has probably more people than just like me working on this, like when I have time. But I did recently make a PPA, personal, forget what that even stands for, but I have a way that I'm trying to update this without somebody having to reinstall the whole thing, which is essentially what I did for a while. I'd work on I'd work on the distro, I'd save where I left off, and then I'd come back to my machine that I build on. I'd build a whole bunch more stuff into it, make an ISO, and everyone would have to like reinstall it again. So I tried to create this repository that, if you follow the guide here, it will add my repo into your install of DragonOS, as long as you have the right DragonOS installed on the desktop, and you do sudo app upgrade. I'm now trying to push packages here without having somebody completely reinstall the whole operating system. So that's something I did, I don't know, a few months ago.
And that's your plan to keep it up to date?
Yeah, what I may do though is if there's big significant changes, like say the new LTE long-term kernel is updated or something like that, I will probably go back and apply all the updates that I've pushed to the repo. I will put that into the ISO with the new kernel, and then put that out there as like a new ISO. So if somebody downloads DragonOS, they're starting fresh. They don't have to start with an older kernel, because maybe they only want to run it live, or maybe the new kernel introduced new hardware support. And if I didn't make a new ISO, they'd be they'd be out of luck. They'd be like, well, I downloaded the other DragonOS, doesn't work. I can't get it to boot on my new laptop or something like that. That may be the only time, but you can still, for the people that do have it installed, I'm trying to keep it to where they can get up to that point. They just might have to do like a sudo app upgrade to pull in the new kernel and go through that on their own. So I'll see how long, this has been going on for, I don't know, about 3 years now or so. I mean, I hope that I can, continue to spend time and refine and make it better. I've stuck to long-term support releases, so I'm not a year into it and then, oh crap, I gotta change everything. I know that Ubuntu has newer releases out, but 22.04 is supported for probably a couple more years. Maybe when the next long-term support comes out, I will work on building a whole new distro on that, but that's probably not, at least for another year.
No, that makes sense. I really appreciate it. I have a lot of homework I want to play around with DragonOS. I'm sorry, I'm scrolling around on DragonOS right now, looking at everything. There's a lot of neat features. What would be your number one feature that or cool thing that you find that you're able to do on DragonOS?
Well, the funny thing is there's a lot of stuff, a lot of tools, open source wise, that I've tried to put in such a way that combining them together makes it. Let me see. So if you have the Kraken SDR, which is out on the market, I don't know, that's a few $100 piece of equipment for direction finding. I have what's called DF Aggregator, which is an open source application that is able to take the information from the Kraken SDR and present it on a map. So I get my idea of where my direction finding system is at. I get the lines of bearing pointing to where maybe a transmitter is that I'm wanting to locate. And then I've built some other tools where you can take that all offline and you can get offline map data. And you can host that map data in DragonOS and combine it with DF Aggregator. And so that's about like 3 or 4 different applications working together to replicate some other, setups that maybe, are used, maybe, I don't know, in the government or whatever. But it's all like open source software combined together. Because that's what I find unique is like, I want to take tools that people have made individually and then combine them in such a way that maybe gets me a different effect or whatever.
Interesting. I'd like to hear talk about that.
Well, if you check out the most recent video I put on YouTube, that was kind of headed that direction. I had the Kraken SDR. I tried to incorporate if you look up 802.11 AH, it's getting back into wireless that's over 900 megahertz. But it's way faster than like LoRa. Maybe not as long as distance, but it's it's like normal Wi-Fi. And I was 1 kilometer away from a Steam Deck that's running, was running DragonOS. I had a Kraken SDR, had a HackerF, and I was remotely accessing that from across the lake at 1 kilometer away, with DragonOS on my laptop. And I was doing exactly what I just described. Like the Kraken SDR information was coming back to me on my laptop on my end. And then in addition, I was having another tool, which is in DragonOS, called SDR for Space. And SDR for Space had control of the HackerF. And the HackerF was listening to a particular frequency. And when that frequency, when a threshold was met, which was me talking on a handheld radio, when that threshold was broken, SDR for Space takes the HackerF, immediately records the IQ data, records that transmission, demodulates it, takes the wave file, which would contain my voice, and sends it over to, all the craze nowadays is all this AI stuff. So in DragonOS, I have built in an open source implementation of OpenAI's Whisper. That's like a program that takes a wave file, listens to the audio, and immediately transcribes it. And so all that was like, that's all in DragonOS and all like working at the same time. So it was like, my thought process was, if I want to find somebody that's talking on a handset, I've got the HackerF tuned to the frequency I'm waiting for. I've got my Kraken SDR on that frequency. Bam, the person talks, transmits. I get what they're saying. I'm getting the lines of bearing shooting at them. Like if I have enough stations set up at different locations, I'm going to get that immediate, intersection where that person's at, and that type of thing.
So I'm thinking like at scale, if you had a couple of these floating around, and let's just say you pipe it into like, you need some sort of data, like put it into like Elk Stack, you can use like that tool you use like Whisper that basically just takes a waveform and things that are said. I think PySpeech does something pretty similar, I think. You're able to then like make a word cloud instead of like IP addresses. You'll make a word cloud of like the most popular word being said, and you can like queue into like what is being said and where what's coming from, right?
Yeah, that would be pretty insane. Yep. Yeah, I was trying to get to the point where my next step was trying to take all those recordings, all those WAV files that had been transcribed, and I was trying to figure out which. I talked to the developer of Whisper CPP or Whisper CP C++, and he makes another application called Llama. I think I'm saying it right. It's like an open source implementation of Facebook's, I guess almost like a Chat GPT thing, and you can run that locally with a model. And I was going to feed it all the text and basically say, hey, make me make me a summary of like what was said today. Something like that.
Yeah, like this, like what's the top news in radio? Like what is the radio stations talking about today? Just a
Yeah.
word cloud.
Yep. Oh,
So just I apologize if I missed that part, but I mean, if you had to sum it up overall, Kraken SDR versus I don't know,
oh,
Blade RF, are they just different beasts?
Yeah, the Kraken SDR is essentially like 5 RTL SDRs packed in one case for the purpose of direction finding. That's not to say that
Got it.
yeah, you can use in Linux the 5 SDRs will come up as 5 SDRs, and you could use those individually to look at have multiple applications running or whatever, but quality wise they're still only RTL SDRs, and the more so what of it is that it's set up to do direction finding. So kind of maybe a different use case than the Blade RF.
Right on. Thanks.
Sure. Hopefully I answered your question. The Blade RF is a pretty nice SDR. It actually has had a recent modification that gives it a pretty unique feature, which is an instantaneous bandwidth at a lower kind of maybe resolution of 122 megasamples per second. You can look at 122 megahertz wide chunk of the spectrum, which I can't think of any other SDR at that price is capable of doing that.
Let me ask you this for full duplex, right? You've
Yep.
got one Blade RF versus 2 hack RFs.
Okay.
Like, because you could have one in sort of a receive mode, like a one hack RF in a receive mode, and the other one reserved for transmit, right? And so that's your full duplex versus a single Blade RF. That'll get you full duplex right there.
Yeah, and yeah, so there maybe is like one application that I can think of that maybe that would benefit or be able to do partially like send and receive, but like for example with the Hacker F or even 2 Hacker Fs, you're never going to be able to run like a GSM network or the LTE network or some of those sophisticated things that it's really relying on one synced up radio doing the send and receive at the same time.
Got it. And that's kind of like where something like the Blade RF will shine.
Yeah, exactly. Yep. Yeah, Blade RF, Lime SDR, any of the the B205 that's getting more probably closer to like $1,000. Those are probably like some of the lower end full duplex SDRs that I can think of. There's a hat. There's a Pi hat that I have here. I'm really hoping that the developer gets things in gear and starts fixing this thing. It's called the Caribou. What the heck is this thing called? The Caribou Lite, and it's literally a software-defined radio that's like smaller than a credit card that can plug onto the top of the Pi. But it's had a lot of issues thus far. Like just the developer's not been very active. It's I had really high hopes for it, and he does seem to be more active recently. But it is a full duplex software-defined radio that literally fits on the top of a Pi, but it can only look at like 4 megahertz wide bandwidth. I want to say it's maybe like 20 megahertz to 6 gigahertz. So it is a very interesting thing, like in a small form factor or whatever, but. I honestly I can't recommend it at this point until this guy gets this thing fixed.
Can you speak to like I don't know, I guess when it comes to antennas, I'm not too up on it, but is there like do you fit the antenna to the thing you're trying to do? Like this is pretty much don't screw around, use this one for GSM, use this one for LTE, or is there like a nice one that kind of covers a lot that you could get away with that you recommend?
I think there's probably like you could spend a good chunk of money and get an antenna that covers pretty wide range of frequencies, but kind of what I have scattered around that I'm looking at is more fit to the specific, like maybe roughly close to the frequency I'm looking at. Like maybe I've got some antennas that have come off wireless routers, or that are for wireless routers that are dual band 2.4 5 gigahertz. I'll kind of use those. I've got antennas that are more down into like the 900 megahertz range, and then some of the antennas that are really meant for HF. I don't really have a good antenna that just all around covers everything. The RTL SDR has a antenna that comes with it. The Hacker F, I think, generally has an antenna that comes with it that they say can work over a wide range of frequencies, from maybe down low 70 megahertz to 1 gigahertz. They claim, but when you start getting into like 2.4 gigahertz, 6 gigahertz, maybe down into HF, you're probably going to find that you're going to have like several antennas laying around. If you guys find one that cover, that you can recommend, that's not a fortune, let me know, because I'd like to replace the 85 antennas that I have laying around here. But well, I guess with that, what was that code to figure out what 4G frequency your phone is using? So at least with my iPhone, it was what was that, pound? Five, maybe. I might have that wrong. Oh, okay, yeah, there we go. I think before and after that, which I don't know why I took it off, was the star. Oh yeah, there you go. Okay.
It's Discord formatting. You had to escape it.
Well, nice. Okay, good. Well, I better jump off of here, because I'm gonna go drink a lot of water and get up early, and not be one of the ones that fall out. So maybe we could do this again sometime. I like doing this stuff. It's just there's just so much to cover, really. And if you think of like things that you want discussed or talked about, I could maybe have a little more like formatting to the presentation. I like doing things in person and just not totally winging it, but like just being interactive with people, and if they run into a problem, show them, or talk a little bit more about something that somebody has an interest in. I kind of like that.
Just curious, like, how did you hear about the Null 404 group?
Oh, I was talking with Neck Kevin here. What is his name on here? Neck Sorty.
Nick Sorte.
Nick Sorty. Oh, okay. Yeah, that's funny. Oh, yeah, but where are all you guys from? Like, how are you? Like, how long has this channel been around? Like, you guys normally on here all the time, or?
It's fairly active. Every Tuesday we have a meetup with. It's been increasing in population and popularity recently, which is kind of the point. But we'll normally have, on average, I don't know, maybe 10 to 15 people on every Tuesday. Normally it's the same crew of folks. The channel has existed for a couple years. It was originally created by Kevin and a couple of other people who aren't on tonight. And to answer your first question, I am currently in the Fort Benning area.
Okay. Yeah, Fort Benning. Yeah. Well, I'm down. More towards Augusta.
Oh, very cool, man.
Yeah. I thought about like it seems like there's a lot of interest in like maybe doing some of this stuff in person. The problem becomes getting time to do it.
I understand.
Yeah, I think the big founder story basically is I actually known so Sean and I know each other from like elementary school. I actually met Sean. I started to get in IT. He was already been in IT, but we both were interested in like CTFs and like cybersecurity in general. And this is like pre-COVID time. We were like, I don't know how to do CTFs. We tried to both do like the first Google CTF together to just like learn together. And we were trying to like reverse engineer assembly with like barely knowing Python.
Yeah.
So it didn't work out well. And we were like, well, let's get together like once a week. We'll meet up like on Tuesday. You teach me a tool, I'll teach you a tool. And then like after a year, we'll get good enough to where we could do a CTF. And that kind of drew in one of our buddies, and kind of slowly grew. Like, hey, I kind of want to do. I know cybersecurity. I kind of know this, and kind of the crew grew, and we kind of were doing stuff behind the scenes. And we just within the past year kind of opened it up to the public of, hey, we're doing cybersecurity research, and here we are.
That's really good. Well, I definitely would suggest digging a little more into some of those applications I showed, because you'll see all the time on Twitter and just articles that'll come up where if you're really interested in like cybersecurity when it comes to LTE and cellular, there is like some really crazy attacks and techniques that are like out there where I think if you dig enough, you'd probably find all the details needed to replicate it. And that's interesting to me. It just takes a lot of time, to just go down the rabbit hole and figure it all out and test it and try it. And maybe I'll get back to where I have a little more time. Things won't be so busy, but yeah.
Yeah, well, I'll be happy to have you. We usually stop around 7:30 ish. Sometimes it runs late, but please join. And we do stuff. Sometimes it's focused on a little bit more privacy. Sometimes it's a little bit more of the cyber flavor of a new tool.
Okay.
And then a little bit we've been doing a little bit more physical and getting involved, getting ready for DEF CON. And so those flavors. Would love to see you out at DEF CON, but totally get it.
Yeah, maybe next time.
Yeah, didn't you present this at DEF CON?
Oh gosh, the
A while back?
What was the RF or RF sanctuary?
About 3 years ago, maybe.
Yeah, they so I knew like a few people there, and they asked me to talk about stuff, but I'm not really good at like. I just try to like come up with something to talk about. I don't even remember what the first one was. It might have just been like, hey, here's DragonOS and here's kind of what it is. And then the next one, I think I tried to show a tool that was in DragonOS and explain how I, got some dude at a university to help. I don't even know what it was. Something about like RF propagation modeling and showing how that works in DragonOS. But yeah, that was kind of like a side thing that they showed during DEF CON. I don't know that I don't know if I could actually say it was like the main DEF CON channel, but I've never actually been there. Only did those two presentations.
All I want to know is how to triangulate the Fed.
Oh yeah.
I don't even want to spot the Fed. I want to triangulate his ass.
Oh, man. Just run around with a few Krakens.
Kraken. Unleash the Kraken.
Yep.